For this section, we're going to talk about some parent functions. Now, what do I mean by a parent function? A parent function is a function that we already know, have studied, and has well-defined behavior. And we're going to do things. We're going to transform these parent functions. So we need to understand where we're starting before we can transform anything. So the first parent function we're going to look at is a line. Y equals x. Now you study the line extensively in Algebra 1. It is odd, which means that f of x is equal to minus f of minus x. So as x becomes infinite in the positive direction, this function becomes infinite in the positive y direction. And as it becomes infinite in the negative x direction, it becomes infinite in the negative y direction. The absolute value of x, we've studied, it is even. It has a domain from negative infinity to positive infinity. And the range does include 0, and it goes from 0 to positive infinity. Now, as you increase in the x direction, the absolute value function goes to positive infinity. And as you go to infinity in the negative direction, the function approaches positive infinity. Now, y equals x squared is called the quadratic function, and it's even. It has a domain from negative infinity to positive infinity. We can put any number in there. There's no restriction. And the range is from 0 to positive infinity. And we can have that 0 in there. Now the square root function is we're going to call the radical function. No, it's not even, it's not odd. It has a domain from 0 to positive infinity. I know it looks like there might be an asymptote there, but there's not. The range is from 0 to positive infinity as well. We don't even talk about anything when x is negative. That doesn't make any sense in our graphing. The cubic function is odd. It has a domain of negative infinity to positive infinity and a range of negative infinity to positive infinity. As x becomes infinite in the x direction, this shoots off to positive infinity pretty quickly, and the same is true. It shoots off to negative infinity pretty quickly. It has this interesting little point right there. We're going to call it an inflection point. And we'll map that inflection point. The cubed root function is also odd. It turns out these two are inverses. And it has a domain of negative infinity to positive infinity and a range of negative infinity to positive infinity as well. Let's look at the where it crosses the axis. The line function, y equals x, has an x and a y-intercept of the origin. The same is true with the absolute value function, the quadratic function. The radical function does cross at 0, 0. It doesn't go all the way through. We're not going to worry about that. The cubic function, again, that inflection point goes through 0, 0. So it has an x and y intercept of 0, 0. And the same is true with the cubed root. So we're going to do a lot of things with the origin, what happens to that key point, and what happens to the intercepts. Now suppose I have some general function. It could be any of the functions that we've already talked about or some random function. They behave in very systematic ways. If I have y is equal to a, where a is just some number, times my function, and the function is of bx minus c, and then plus d. We're adding this d on the end. These are going to affect our function in very regular ways. For example, vertical shift up. Think about it. This is my y value. If I add something to the outside of the function, it is going to be a vertical shift up. So if d is positive, it'll be a shift up. If d is negative, it'll be a shift down. Now let's think about what is going to vertically shrink and vertically stretch. The D is not, it's going to move it up and down. But let's look at this A right here. If A is between 0 and 1, it's going to shrink. While if A is greater than 1, it's going to stretch it. Now let's just do the absolute value here because that really is important. Now a vertical reflection is going to occur whenever A is negative. Now you can have a vertical reflection that's a shrink or a stretch. Now let's switch over and look at the horizontals. Now first of all, before we do the verticals, look, the verticals kind of bookend it. It's multiplied by the functional part or added to the functional part. Now what about when we are dealing with the horizontal shifts? Well, a horizontal shift to the right will be when C is greater than 0. A horizontal shift to the left will be when C is less than 0. Do you see how this is almost opposite what you would think? Here you're adding D and that shifts it up, but here you subtract C when C is positive. That's a right shift. A horizontal shrink is going to involve this B factor. So you're going to have a horizontal shrink when B is greater than 1, or when the absolute value of B is greater than 1. And you're going to have a horizontal stretch when B, the absolute value of B, is between 0 and 1. You'll have a horizontal reflection that reflects it across the y-axis when you have B is less than 0. Here's a summary. You might want to pause and write those down. Now what I want to do is show you a demonstration with one function. So here's a function, y equals x squared. Plain old y equals x squared. And I want to change one element at a time and show you what happens to the function. The first thing I'm going to do is move D. So we discussed this is going to move it vertically up and down. So as D becomes positive, it's going to shift it up. When D becomes negative, it shifts it down. So what you add on the end vertically shifts it up or down. Now let's look at the vertical stretch. That's A. When A is greater than 1, it vertically stretches it. Think about what I'm saying there. If I'm at this point right here, it's going to stretch it up to here. Now also notice what happens to the bowl. As the bowl becomes more narrow, the larger the leading coefficient is. Let me take it back. What happens when A is between 0 and 1? You're going to get this vertical shrink between 0 and 1. Now, when I take A and make it negative, there I get my vertical reflection, and vertical reflections are always across the x-axis. So let me take this back to 1. Let's look at B. B is going to be a vertical stretch or shrink. So when B is greater than 1, we're going to have a vertical, or excuse me, B is going to give you a horizontal stretch or shrink. When B is greater than 1, you have this horizontal shrink. Think about it. It's taking this point here and pushing it in there. When B is between 0 and 1, you get a horizontal stretch. I'm sorry, I keep saying vertical. Now you're not really going to be able to see it when it's negative, but it reflects it across the axis. Let me give you an odd function here and show you what happens when you have that. All right, let me change this one as well. So this is y cubed. Y is equal to x cubed. All right, so let me make B positive again. See, it's got the same behavior, but when B becomes negative, it reflects it across the across the y-axis here. Let me take this back to the squares because I do want to finish showing you the shifting with the squared function. All right, let me put b back to 1. All right, now let's look at what happens when we shift c. This is one that loses a lot of students. When I move c and make c positive, and we're subtracting, it moves it to the right. When c is negative, it moves it to the left. So when you see x plus 5, that means it's a shift to the left. And there is the review again. Make sure you have those down.